Welcome to Fact Turtle. Aditya L1, India's first solar-based mission. Yes, you heard it right. After successful moon mission, India has now launched its first ever space-based observatory-class solar mission Aditya L1 to study the Sun. The total cost of the mission is estimated to be around 4 billion in India rupees. The name of the mission is derived from Sanskrit name for the Sun, Aditya. The date for the launch of India's first-ever solar mission was September 2, 2023. The suite of 7 Aditya L1 payloads is expected to provide information regarding problems of coronal heating, coronal mass ejection, pre-flare and flare activities, and their characteristics, dynamics of space weather, study of the propagation of particles, and fields in the interplanetary medium, etc. The spacecraft carries 7 scientific payloads for systematic study of the Sun. All payloads are indigenously developed in collaboration with various ISRO centers. VLC, Visible Emission Line Coronagraph, is designed to study solar corona and the dynamics of coronal mass ejections. The payload is developed by the Indian Institute of Astrophysics, Bengaluru, in close collaboration with ISRO. SUIT, Solar Ultraviolet Imaging Telescope, to image the solar photosphere and chromosphere in near ultraviolet, UV, and to measure the solar irradiance variations in near UV. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, in close collaboration with ISRO. Solar Low Energy X-ray Spectrometer, SOLEXS, and High Energy L1 Orbiting X-ray Spectrometer, HEL1OS, are designed to study the X-ray flares from the Sun over a wide X-ray energy range. Both these payloads are developed at U.R. Rao Satellite Center, Bengaluru. Aditya Solar Wind Particle Experiment, Aspects, and Plasma Analyzer Package for Aditya, PAPA, payloads are designed to study the solar wind and energetic ions, as well as their energy distribution. Aspects was developed at the Physical Research Laboratory, Ahmedabad. PAPA was developed at Space Physics Laboratory, Vikram Sarabhai Space Center. Magnetometer, MAG, payload is capable of measuring interplanetary magnetic fields at the L1 point. The payload is developed at Laboratory for Electro-Optic Systems, Bengaluru. Aditya L1 Observatory will be placed in a halo orbit around the Lagrangian point, L1, of the Sun-Earth system, which is about 1.5 million kilometers from the Earth. A satellite placed in the halo orbit around the L1 point has the major advantage of continuously viewing the Sun without any occultation or eclipses. This will provide a greater advantage of observing the solar activities and its effect on space weather in real time. Lagrange points are named in honor of Italian-French mathematician Joseph-Louis Lagrange. Lagrange points are positions in space where objects sent there tend to stay put. At Lagrange points, the gravitational pull of two large masses, in this case the Sun and the Earth, precisely equals the centripetal force required for a small object to move with them. These points in space can be used by spacecraft to reduce fuel consumption needed to remain in position. In other words, they are perfect parking spots for satellites. But the question is, why ISRO wants to study the Sun? Firstly, the Sun's close proximity from Earth. As the Sun is the nearest star and therefore can be studied in much more detail as compared to other stars. The second point is, by studying the Sun, scientists learn much more about stars in our Milky Way as well as about stars in various other galaxies. The third and most important point is that the Sun shows several eruptive phenomena and releases immense amount of energy in the solar system. If such explosive solar phenomena is directed towards the Earth, it could cause various types of disturbances in the near-Earth space environment. Various spacecraft and communication systems are prone to such disturbances, and therefore an early warning of such events is important for taking corrective measures beforehand. In addition to these, if an astronaut is directly exposed to such explosive phenomena, he or she would be in danger. The various thermal and magnetic phenomena on the Sun are of extreme nature. Thus, the Sun also provides a good natural laboratory to understand those phenomena which cannot be directly studied in the lab. These studies will also help in the preparation of Gaganyaan, India's first human spaceflight missions. This data collected by Aditya L1 will help in the success of Gaganyaan mission and also help protect Indian astronauts while in space. According to the information, Aditya L1 is expected to reach its L1 point in the orbit around Sun in 126 days after its launch, that is 4 months, and with start study the Sun form the month of January 2024, and it will continue to operate for next 5 years. If you liked this content, then press the like button and share it with your friends and family. Thank you for watching.